This is Tech Math 2, and we're in section 9-5 and 9-6 today. And we're going to do logs all over again, but this time we're going to use natural logs. The base of the natural log is E, 2.718281828. It's a transcendental number. It never repeats itself. It keeps on going forever and ever, sort of like pi. And we remember it because 1828 is the year that the first public high school was established, one in New York City and one in Boston. Before that time, all high schools were private, and you got to pay for them. Well, you still got to pay for them because you're the taxpayer, but that's beside the point. In here, we introduce a new idea, which is the log. Any log base b of x is going to be log of x divided by the log of b. And because of some reason, probably because the heavens and the earth were created by God, this is also the natural log of x divided by the natural log of b. So if I have log base 7.23 of 8.75, and I put in my calculator log 8.75 divided by log of 7.23, I end up with 1.0964568829. And if I take the natural log of 8.75 divided by the natural log of 7.23, natural log 8.75 divided by natural log 7.23, I end up with 1.0964568829, the same number. Now, I don't remember why that's the case, and I apologize for that. I probably never knew why that was the case. I just know that it is the case. But there has to be some fundamental reason for that. And of course, if I did, I could do the same thing with any base, right? I could go log base 2 of 8.75 divided by log base 2 of 7.23, and I would get the same number, 1.0964568829. And why? Well, because that'd be common log 8.75 divided by common log 2. This would be 7.23 divided by common log 2. The common log 2's go away. I'd have the same number. Okay, so the issue is we're doing problem number 1, and I want e squared. So I put in my calculator and I hit e squared, and I hit the enter button, and I get 7.389. And I'm supposed to get these things to 3 significant digits, so I would call that 7.39. And then we'll look at number 3. And again, I'm supposed to get 3 significant digits. I want e to the 6. So I go to my calculator, e raised to the 6th power. And I get, how can that be? Oh, 403. Yeah, 403. Okay, good. And that'd be the 3 significant digits as well. We look at number 20. That'd be good, number 20. And I'm doing the same thing, e to the minus 5 over 6. And e raised to the minus 5 over 6, close parentheses. And I get 0.435. 434. I keep the even number. I might round it up. I might not. Okay, questions about that? Then we're just going to do the same thing over again, taking natural logs of things. So we'll take the natural log of 1/845, which is 24, and we'll do 26. Natural log of 0.705, and we'll do 27. We're going to do 27? Yeah, 27. And 27 natural log 0.00582. Okay, well, and again, we're just putting them in our calculator. It's nothing we can, there's no way we can get these other than doing it in our calculator, so that's what we're going to do. 1/845, 7.52, natural log 0.705. You guys do notice that I am wearing my Yukon tie, 0.349. I would round that up to minus 0.350 for my final answer if I was going to do it. Natural log 0.00582. And minus 5.15. Okay, well, I guess we did those guys. I guess we can do, no, we're not going to do that. Compound, do we care about compound interest? I guess we do. We'll go to 42 for a moment and do a compound interest. Well, I guess we got to do 41. So we move back to 41. The population of a city, is 95,000. The growth rate is 3.1% per year. What's the population after 10 years? Okay, so population at times t is population naught e to the rate t is the formula we're using. Now, we don't, we're given that formula, but in chapter 29, we'd actually be able to show that that's the case. All right, so we're going to do that. Population 95,000 e to the 0.031 times 10. And now the issue is, do we want to show it earlier than before chapter 29? And the answer is probably no. You're probably not interested in that. 95000 times e raised to the 0.31. And it looks like I've got 129525. And then I'd say, well, you know, I probably don't have 3 significant digits, so that's probably 130,000 would probably be a better number. All right, and guess what else goes up and down exponentially? Well, let's see, inductors charge exponentially, capacitors charge exponentially, right? So we have V at times T is equal to V naught e to the minus tau T over tau or whatever, T, yeah, whatever it is. So capacitors are charging exponentially as well. That's 41. There we go. We'll do 48 next. A certain electric circuit So the current in the circuit is E over R. What's E over R? All right, so what's E over R? See, V is equal to IR, right? So I is equal to V over R. So E over R, E is the voltage. So there's no difference in using an E or using a V. 1 minus E to the minus R over L T. So my time constant tau is R over L for an inductive circuit. So this is an inductive circuit. And amps are in I, and V are in voltage is E, and ohms and resistance and time, and L is in Henry. Okay, find I when the voltage is 12. Okay, so I is equal to 12, and the resistance is futile, but it's 90. 1 minus E to the minus resistance is 90, divided by inductance. 8 Henry, any idea how big an 8.5 Henry inductor is? That's huge. That's the size of the desk over there. That's a huge thing. Thank you very much, author, for having a realistic problem. 0.012 seconds. All right. So that's what we're doing. So it's a matter of can I put it in my calculator and have my calculator give me the right answer? 12 divided by 90 times, open parentheses, 1 minus E raised to the minus 90 divided by 8.5 times 0.012, right? Not 125. 12, close parentheses, boom. So it looks like my current is 15.9 milliamps. 15.9 milliamps at 12 milliseconds. All right. Now, as time gets bigger, this exponential gets smaller, and my current ends up having a maximum of 12 divided by 90. So my maximum current is going to be 133 milliamps. So I'm heading towards 133 milliamps, but at the end of 12 milliseconds, I'm only at 15.9. Well, isn't that just lovely? Okay, so that was 40. Did we do 41? Yeah, we did 41. All right, now we're going to go and find 68. Okay, we can do 68. Number 68. Log base 7 of 16.5. And we say that's going to be the same as log 16.5 over log 7. Or we could get really wild and call it natural log 16.5 over natural log 7, and would end up with the same exact number. And we've already done that many times before. Now you can't put natural log on top and log on the bottom. That doesn't work. Or common log on top, natural log on the bottom. That doesn't work. You have to use the same one. So log 16.5 divided by log 7. And looks like 1.44. How many significant digits? 3. Okay, so that's good enough. And if we did natural log 16.5 divided by natural log 7, it's the same. And I'd want to use natural log on my calculator because I only have to push the button once to get it, right? So that would cut down my keystrokes using natural log. 1.44. Okay, now we're going to solve. We're going to go to section 9.6 and solve for x. Now, how many times have we solved for x? seems like that's all we ever do, right? Just solve for x. So that's what we're continuing our solving for x. All right, we'll start with number 1. And 3 to the x is equal to 12. And we say, well, isn't that convenient? Well, if I take the natural log of both sides, if I do that, then I can say that this is x natural log x. Natural log 3 is equal to natural log 12. And I can say x is equal to natural log 3, natural log 12, divided by natural log 3. I can do that. And now I take my calculator. Natural log 12 divided by natural log 3. Now again, I could have used common log, and I didn't. How many significant digits? 3. 2.26. 2.26. Then I'll check my work. 3 raised to the answer, which is 10 significant digits long, gives me 12. So I have 3 to the 2.26 giving me 12. When I use all 10 significant digits, if I just go 3 raised to the 2.26 without the other significant digits, I end up getting 1.9755, which rounds up to 12 anyway. Okay, enough there. Number 3 looks like a cool problem. Number 3, 2 to the minus x is 43.7. So we'll take the natural log of both sides, because that's the easiest to use in my calculator, natural log. But there's no wrong. You could take common log, and then I'd have minus x natural log 2 is equal to natural log 43.7 minus x is natural log 43.7 divided by natural log 2. X is going to be minus whatever that answer is. Natural log 43.7 divided by natural log 2 minus 5.45. Then we'll go and check our work and say what is 2 to the minus 5.45. Okay, so 2 raised to the 5.45, boom, and I get 43.7. Am I supposed to get 43.7? Yes, I am. Okay, check. All right, well, let's do 8 next. Two 2x plus 1 is equal to 5 to the x. All right, I'm just going to take the natural log of both sides. And what am I going to do with that, I wonder? And then, oh well, I don't necessarily have to do that, right? 2 minus natural log 5 over natural log 2. X is equal to minus 1. X is equal to minus 1 divided by 2 minus natural log 5 divided by natural log 2. Now, I'm probably not going to do that. I'm probably going to come up here and rewrite this. 2x plus 1 is equal to natural log 5 divided by natural log 2, 2.23. 2.32x So 0.32x with a minus sign is equal to minus 1. X is going to be equal to 1 over 0.23. X is going to equal 1 divided by 0.23. Boom. 4.35. Okay, now I could have just as well come down here and used this guy, so I'm going to use that guy next. See if I come up with the right answer. Minus 1 divided by parentheses 2 minus natural log 5 close parentheses divided by natural log 2 close parentheses equals. And if I do it that way, I get a 3.106. So, yeah. So I wonder which one's right. So I got this. I put it over there. I do that. I put the negative sign over there. And I got minus. Did I put a minus? Yeah, I did. It would seem to the casual observer that I should be getting the same answer, shouldn't I? Natural log 5 divided by natural log 2. 2.32. I put it on the other side of the equation. I get minus 0.32. I get 1 divided by 0.32. 1 divided by 0.32. I get the same thing. Now, how come I don't get it going the other way? That's a good question. That's a really good question. All right, well, we'll use the calculator to go solve numerically. So that's the second function, the guy above the sign in arc sign. 2 raised to 2 times x plus 1 is equal to, wrong key, 2 raised to the 2 times x plus 1 is equal to 5 raised to the x. Boom. And we're going to guess that the answer is 3.5. 3.5, because I have to put in a guess. All right, solving. Quit. It quit. Actually, no, it didn't. It gave me an answer of 3.106. Wow. Way to go. So the calculator says the answer is 3.106. Now we got to figure out what in the world am I doing wrong.
Yeah, I'm at 2.32.
Yeah.
When you subtracted the
when I put it on the other side,
right,
which makes it minus 0.32, and I put this on the other side, making it minus 1.
right.
And why is this 0.32 and this is 0.23? Is that what you're asking?
I didn't see that. Yeah,
Oh, you didn't see that one? It would seem like whatever I have here, I should have over there. You know, just to the casual observer. Does that seem that way to you, Wyatt? That it'd be, yeah, it seems that way. And I imagine that if I take 1, and I divide it by 0.32, I end up with a 3.125, which means I'd have to carry some more significant digits. But I think it's really cool that my numerical solve guy will solve that guy directly for me, and now all I have to do is know how to use it. All right, well, that's good. Good to know that. So that's second function, the key above sign, arc sign, is in blue. It says numerical solve. N-U-M solve. And that's what you want to do. And it gives you an equal sign. You put something on both sides of the equal sign. And then it wants you to make a guess as to how close you want to, some guess. Okay, well that was nice. Number 10, we're going to do to 4 significant digits. Okay, and we're gonna use my numerical solve thing because now I know how to use it, and we're going to solve it first and then come up with the answer second. So 5 times 2 raised to the x plus 16, x plus 16. All right, and that's going to 5 times 2 raised to the x plus 16, and that's going to equal 382. 382. Okay, so we look at that and we say, well, if 5 goes into there, that's less than 100. X is going to be around 7, maybe 6. X is going to be around 6. Okay, so we'll hit enter. We'll guess that 6 is the answer, and we'll tell it to solve it. And my glorious calculator says the correct answer is 5.266786541. Okay, but we only want 4 significant digits, so we wouldn't get that. All right, so I'm not using my calculator this time. 5, 2x plus 16, 382. 2x to the x plus 16 is equal to 382 divided by 5. 76.4. I take the natural log of both sides. I could just as well take the common log of both sides, and I'd have x plus 16 is equal to natural log 76.4 divided by natural log 2, and I'd have x is equal to minus 16. I don't think I put the right thing in my I think I put a 6 there, didn't I? Yeah, I did. That's wrong.
When you type in 5 times the 2, you didn't put the x in there?
Yeah, I did. I'm going to do this guy again because I only put a x plus 6, and it's x plus 16 is what we're solving. So I'm going to do it again. Numeric solve. So I got a 5. I've got a x plus 16. And in this case, it's going to be some negative number, isn't it? We'll put in a negative 5, see if that works. And so my answer now is minus 9.733213459 out of my glorious calculator, seeing that I put the right answer in. Okay, so I got minus 16 plus natural log 76.4 divided by natural log 2. Okay, so minus 16 plus natural log 76.4 divided by natural log 2, and I get a minus 9.74449927. That doesn't seem like it's exactly right. Wow, look at that. Well, I rounded this guy off when I rounded. What did I round off? I didn't round anything off. Why would I be that far away?
Okay.
Yeah.
When you put it in the calculator,
Yeah.
you did 5 times 2x plus 16. Now you figure equals to 382. You put 382.
And then you guess. I'm going to guess a minus 4.
Okay.
do a numerical sum around there, and it's going to go and tell us what the bill answer is, but it's 9.744. Well, how come you got something that's as good as I did? I must have put in the wrong number when I got the other one. So, Nate's calculator is doing exactly what it's supposed to be doing. Mine is hosed over because the operator can't put the right stuff in it. Okay, so that guy's wrong too, because I fat fingered some key someplace. Okay, but yeah, I'm really happy with that calculator work. Huh? Pretty cool. 10 more minutes to goof off. We'll do 20. Oh, did we do 14? We'll do 14. Uh, 10 to the x, 1.35. X natural log. Oh, we'll use common log. Common log 10 is equal to common log 1.35. And common log 10 is 1, so x is equal to the log of 1.35. All right, so common log 1.35, 0.1303, and we want it to 4 significant digits. Yes, we do. Okay, excellent. So that would be 14. Now we'll look at 20. E to the minus 2x, 0.00448. And if we take the natural log of both sides, we end up with minus 2x is natural log 0.00448, and that x is minus natural log 0.00448 divided by 2. All right. Minus natural log 0.00448 divided by 2 is 2.704? 2.704. Okay, check our work. Check our work. E raised to the minus 2 times the answer gives me, if I go e to the minus 2x, gives me 0.00448, which is exactly what I was supposed to get. Okay, so that's good. All right, excellent. 49. Number 49. 7 is 10. 1 plus e to the x over 2. 0.7 is 1 plus e x over 2. The natural log of 0.7 is x over 2, the natural log of 1 plus e. X is equal to 2 natural log 0.7 divided by natural log 1 plus e. All right. So I guess we'll have to do that. Well, we'll use the numerical solve guy again. Numerical solve. I got 0.7 is equal to parentheses 1 plus e close parentheses raised to the x over 2. Now, where do we think this is going? I think this is a negative number. So I'm going to put in my guess, I'm going to put in negative 0.5 for my guess. All right, and the calculator magically tells me it's the correct answer is minus 0.543189444. All right, so we're going to come back down to this guy. 2 times the natural log of 0.7 divided by natural log of 1 plus e. And to put an e in, I got to go e raised to the 1 power. Close parentheses, boom. And this answer becomes minus 5, minus 0, 0.5431895. Yeah, that's the same answer. Wow. Guess it's.
How do you check that again?
How did I do this? Or how did I do that?
We're checking the natural log.
Yeah, I didn't. I just entered that directly into my calculator. All right. Well, we have to do an electronics problem. So 56. EAS. I wonder what that stands for. 50 volts. Voltage naught, 30 volts. My time constant. Time constant's a tau, you stupid author. Microseconds. In the time 150 microseconds. The 3-second period. Find E naught. Alright, so from the equation, V naught, which is 30, is equal to EAS, which is 50, minus EAS, which is another 50, minus E naught, which is what we're supposed to find, times E to the minus T, 150 microseconds, divided by the time constant. Is that divided by the time constant? 90 microseconds. All right. So I'm going to put this on the other side of the equation to get rid of the minus sign. So I got 20 is equal to 50 minus E naught, e to the minus. Let's see, 15 divided by 90 by 9 is what? 1 2/3. 1 2/3. Okay, what are we going to do? Oh, we're just going to solve it. Okay, so 20, 50 minus E naught, and now I want E raised to the answer that I just got, and that's going to be, but it's minus. Bummer.
Would that be a negative form?
I know. Where? No, it's not. Because it was a negative 20, but then I brought this minus sign on the other side too, and multiplied both sides by minus 1. Yeah, I hosed this over really bad. Okay, E raised to the minus 5/3. 5/3. All right, E to the minus 5/3. 0.18887. All right. So now I've got 20 minus 50 times the answer is going to be 10.556 is equal to minus E naught times 0.18887. Okay, so E naught is going to be minus 10.556 divided by 0.18887. Right, so I got that answer already there. Okay, so I'm going to divide by 0.18887 ohm. 55.89 volts, and then I'm going to say I probably only have 3 significant digits. So for my final answer, I would call it minus 55.9. All right, now we're going to move all the way up to the top and use my numerical solve. Numerical solve, 30 equals 50 minus, open parentheses, 50 minus x, close parentheses, times e to the minus 5/3. Then I got to get rid of the extra stuff. Okay, there we go. And I'm going to guess, what I'm going to guess my answer is about. I'm going to guess it's about 50. 50, boom, boom. And it tells me the correct answer is minus 55.88980101. It looks like I did about the same there, didn't I? Wow.
Still having fun?
Oh yeah. We're practicing using the numerical solve on my
Oh,
calculator.
we did that last week.
Yeah, it's really cool. Okay, good enough, gentlemen.
Trying to find the Q points of those J points.
Oh yeah.
We're pretty good.
Yeah.
But you've just got to be able to recognize when you're on the wrong side of the problem.
Just in case anybody wants to know, that's the voice of Eric Kennedy on the video.
Sorry.